Hello. This video is meant to accompany Algebra 1 Notes 7.2 and Homework 7.2. The topic for the lesson is simplifying radical expressions. So just some vocabulary first, and this should be a review from Course 3. A radical is just this symbol, which until now you probably called a square root symbol. It's called a radical. The number that is under the roof of the radical is called the radicand. And this little number 3 here is called the index. The index tells you what type of root you're taking. So in this case, we're taking a cube root because the index is a 3. Please note that if there is no index shown, then you're taking a square root. For example, if all you see is this, then that means it's a square root. There is no need to write the index of 2. It's assumed that it's a square root if there is no index written. So as you can see here, the cube root of 27 is 3 because 3 times 3 times 3 is 27. In order to simplify a radical expression, then you cannot leave any number or any quantity in the radicand that can be rooted. In this case, it's a square root. So I have to remove any squares that I have under the roof. Now I can see that there is an n squared, and we can take the square root of n squared. But there could also be hidden perfect squares inside the radicand. So we want to find any numbers that are perfect squares that are hiding inside this 12. So what we can do is we can factor everything in the radicand until we break it down into prime numbers, which is called prime factorization. So if we take the 12, we can break that 12 down into 6 times 2. We can break down the n squared into n times n. We can continue to break that down even further because 6 breaks down to 3 times 2. And notice this 2 is still there, as are the 2 n's from the n squared. So now we have factored 12n squared down to its prime factors. Now we're looking for perfect squares. Now we have 2 perfect squares because I see 2 times 2 and n times n. Those are both perfect squares. So we can take a square root of both of them. So what happens is when I take the square root of 2 times 2, we're going to bring it outside of the radical. Same thing for the n squared. When I square root it, it will come out of the radical. So what I'll be left with is 2 times 2 is 4, and when I square root 4, I get 2. So this will equal 2n radical 3. Now the 3 is still here because we never square rooted that 3. So it stays under the radical roof. 2 times 2 is a perfect square, so it came out of the radical and became this 2 in front of the radical. N times n is a perfect square. I square root it, bring it out of the radical, and it becomes the n in front. Let's look at the next example on your notes. So on this one, we want to break down the radicand into as many perfect squares as we can. So maybe you notice that 75 can be broken down into 2 times 25. So this can give me 2 times square root of 25 times 2 times x squared. So the 75 became 25 times 2. Now I have a perfect square here and a perfect square here. Both of those perfect squares are going to come out of the radical, and we will square root them. The 25 will come out as a 5. So I end up with 2, because this 2 still is in front. So I'll get 2 times 5, because square root of 25 is 5. The square root of x squared is x times radical 2, because this 2 stays under the radical. Now I will simplify this by multiplying the coefficients together, and I get 10x square root of 2. How about this next example? Notice this one is a little bit different because now I have this exponent that's an odd number. So how do we handle that? If we have an odd number exponent, there's a certain way we can do this. So as you can see, I wrote this out as being x to some power squared. Now, if we think back to our power to a power rule, we remember that we multiply the two exponents to get x to the 6th. So we'll put a number inside that box so that when we multiply this exponent and this exponent, it will equal 6. So clearly we'll put a 3 in that box. But what about our y? Is there a number I can put in this box that I multiply by 2 and have it equal 7? Well, there is. If we put a 3 in the box, knowing that 3 times 2 is 6, and that leaves us 1 short. So we just multiply by another y. And this is y to the 1. So now I have y to the 6th here and y to the 1 here, which gives me y to the 7th. So it will look like this, except we'll add our additional y so that now it's equivalent to the original radical expression. So now what happens is we have a perfect square here. We have a perfect square here. Both of these will come out of the radical. So after it comes out of the radical, what we will end up with is this. The square root of x cubed squared is x cubed. The square root of y cubed squared is y cubed. However, we're left with this oddball y, so we put radical y, and that's our answer. And that's the same problem, so we'll skip that. All right, next up. How will we break this down into perfect squares? Well, the first thing we'll do is express the 24 as 4 times 6. Now notice that I did 4 times 6. I did not do 3 times 8. The reason why is because 4 is a perfect square. So I can take the square root of 4. It will come out of the radical. If I did 3 times 8, neither one of those is a perfect square. So I could not extract a perfect square from the radical. The a to the 5th power becomes a squared squared times a. The b to the 15th power becomes b to the 7th squared times b. Now I have 3 perfect squares, all 3 of which will be extracted from the radical, and they'll move to be in front of the radical. So I will end up with square root of 4 gives me 2. Square root of a squared squared is a squared. The square root of b to the 7th squared is b to the 7th. And I'm left with 6ab under the radical, because there are no more perfect squares under the radical. All right, let's look at a few examples from the assignment. Number 4 from the assignment, we're pretty much combining like terms here. What we want to do is simplify each radical so that we can add together like radicals. So here's how it'll work. 2 radical 2 is already simplified. There's nothing I can do with it. This 2 radical 2 is also already simplified. But if your number sense is awake, you'll notice 2 radical 2 minus 2 radical 2 is 0. So we can ignore those. Now we are looking for a perfect square hiding inside the 18 and a perfect square hiding inside the 20. Let's do both of these separately. So this one will end up being negative. Don't forget there is a negative in front. Square root of what perfect square divides into 18? It would be 9. Then we'll do this one, which gives us minus 3, because we cannot ignore that. Radical. What perfect square can we divide out of 20? 4 times 5. 4 is a perfect square. 9 is a perfect square. The 9 will come out of the radical. The 4 will come out of the radical. And we will be left with, when I pull out the 9 from the radical, it becomes a 3. When I remove the 4 from the radical, it becomes a 2. which multiplies by the -3 that's already there, and I get -6 radical 5. This is our answer because the radicands are simplified and contain no perfect squares. Let's move on to number 16. On number 16, don't be thrown off by the negative sign in front. It will remain, and we'll draw a really big radical here. I need to break down 200 by finding a perfect square that divides out of 200. That's going to be 100 times 2. The x cubed is going to become x squared times x to the 1. Remembering that when you add the exponents, they will give you the x cubed. Then I will get, that's supposed to be times, y squared squared. And that's y to the 4th. So now I have a perfect square in 100, x squared, and y squared squared. Each one of these will come out of the radical. And we will end up with negative, because the negative sign is still there. Square root of 100 is 10. Square root of x squared is x. Square root of y squared squared is y squared times radical. This 2 and this x will remain. And there's my answer. All right, so if you have any questions on any of these, you can send me a message on Remind, or send me an email, or post something on Google Classroom. But Remind is the easiest way to get a hold of me during the school closure. I will answer your questions on the weekends or in the evenings. That's fine, as long as I'm not busy. And if you message me, I will get back to you as soon as I can. I hope things are going well for you during this school closure, and that you guys are staying safe and helping to take care of the needs of your family. And I'll see you soon.